Hey, hey everyone, this is Nishant, and I'm the founder and CEO of Vyorius. At Vyorius, we are basically seeking to transform the unmanned robotic infrastructure uh, in a very similar way to what AWS did to cloud computing. Just to give you a quick background, I am personally coming with a manufacturing background, where in 2019, essentially, we created long-range drones that can travel 100 kilometers, carry 5 kg medical supplies, and the idea was essentially to create a logistics network using those systems. We were working in Poland at the time and we did our trials. And pretty soon we realized that there's a major challenge, basically disparities in terms of how robotic automation and operations are being handled at this moment. Uh, we all know and we all understand that we are entering this new age of robotics. Everyone is talking about newer stuff, cooler stuff, better products. Uh, but then at the end of the day, we all are thinking how they can actually be integrated into real world workflows, how we can actually use them at scale and manage them at scale. And this is where we are targeting and what we realized after those running those operations in Poland with our own sort of a smaller delivery network. So what we understood was that as an enterprise or an operator, your major challenge could be initially definitely to prove the individual's robotic system. It should work fine, it should work robustly. But once that is done, once you are actually looking to to implement in real world, then your major challenge becomes how robust your integration of a fleet of these robotic systems could. As a manufacturers, you basically want to sell more. As an operator, you want to do more, and that can only happen if multiple number of these robotic systems can cohesively work together, and humans can also interact with them with the same seamlessness that we communicate with each other. So with that understanding, we started focusing on how pilots safety, telematics and reporting and regulatory compliances should come into picture, should work together in a seamless single workflow. And then we realized that there are certain barriers to the economic feasibility of these robotic systems, of the operations that they entail. uh, Coming from the enterprise background, what we realized that currently any application out there is basically pretty much hardware dependent at this moment. So if you change the hardware, and there definitely couldn't be a one single solution fits all kind of thing. So if you believe that you build one stack and then you can use it at any place that you want to, this definitely would not be the real world scenario. You will need to change a few things, or you might need to tinker around, but something somewhere needs to change when it comes to the hardware. And when that happens, then your entire team, the pilots as well as the other people who are maintaining them, managing them, all manually, which is being done right now, needs to get retrained. Now, as an enterprise, which is actually completely focused on a single operation, that could be logistics, that could be agriculture, that could be remote supervision, surveillance, any of that, this creates a bottleneck. This creates a bottleneck with the fact that, are you flexible enough to choose specific hardware? Are you flexible enough, let's say when the time needs, then you can adopt and change into any of the best solution available? So this sort of creates a bottleneck. Then as you increase the size, the system reliability keeps on falling down. And that is based on the fact that you don't understand how exactly the workload distribution is happening. So you could be having 10 different drones or 10 different robotic systems. Each of them looks same, behaves the same. As an operator, as a human looking at them, you cannot perceive which one is which. So if that is the case, then how you can make sure that all these different robotic systems basically are doing similar kind of jobs, similar amount of jobs. So that is also something that comes into consideration, and that's why having multiple teams and assets sort of becomes a huge problem. Once that is done, once that is settled, you have already taken care of, uh, then it's the aspect that's inevitable. Things are going to be breaking down, and you will need to do maintenance. So how exactly you can automate and digitize that? Because right now the only way possible is to do it manually. So this definitely doesn't cut the case, and you need something better, something more of even predictive in nature, where even before the system breaks down, you get to understand that you can actually do something about it. Then something that we already are aware about, compliance and documentation becomes the biggest hurdle, and there needs to be certain standards which definitely the Indian government and governments across the globe are working towards. But as operators, as industry leaders, as people who are working to nurture this, we should also create some sort of internal standards that can make things easier for governments out there, for regulatory bodies out there, to meet up to their criteria. And that is something that we figured out. And lastly, we realized that even if all these things are good, great, amazing, the problem remains how you can actually integrate these robotic systems into real world workflows. How the system can be as transparent and as mature as you guys just ordering an Uber, and looking at your mobile phone and seeing who is piloting, who is driving the Uber, and where exactly it is and how long it will take and things like that. And this is because now is the time we are basically sitting in the environment where every individual client out there is actually looking to get that same customer experience that he's getting. So if the Uber is providing a better experience than, let's say, your self-driving car, then the other person might move towards just a manually drive Uber, so as to say. So with that understanding, and with all these different segments, we realize that there's a need of a back-end digital infrastructure which can actually support any kind of unmanned robotic operation out there. And these could be drones, rovers, ships, self-driving cars, trucks, whatever in the future. But idea remains the same, that how we can manage the fleets of these robotic systems at scale. So with that understanding, we got to a solution. We are placing ourselves as an AWS of unmanned robotic operation out there. We are creating an AI-enabled plug-and-play sort of a hardware agnostic software architecture, which has nothing to do how your robot works and how it functions, but has absolutely everything to do with how it interacts with the humans involved. And with that understanding, what we are claiming and what we are trying to do is basically provide the flexibility which I was talking before to the operators and enterprises to choose any hardware system possible at any point of time without the need to retrain any of your pilots and any of their workforces. We are aiming to basically remotely manage your entire systems, uh, with the fact that we maintain the reliability while you keep on increasing the fleet sizes and the team sizes, so that asset management basically comes into picture and it becomes completely second nature, completely automated and highly digital in its own sense. Then we essentially are trying to provide predictive maintenance capability within these systems. These systems could belong to any manufacturer, to could look like anything, any configuration, but at least there should be the capability where we can actually control the errors, the unauthorized accesses with these systems, as well as the mechanical failures before they happen. So there we can provide something like that. This is what we are working on. We are working on to automate the data logging. So we all understand that in an aircraft you have got a black box, and in drones and robotic systems, every time you do a function, you do a mission, they generate sort of a log file, and that file, we believe, would be the most important criteria for regulatory bodies to to any point of time come to you and ask you for those specific data sets, because those data sets can provide and will provide the complete transparency that what exactly happened at the time. I mean, everything could go absolutely perfectly, but then you will need to make sure that those logs and missions files are absolutely safeguarded, so that at any point of time they can actually be provided back to the regulators and the bodies. And they will also help you in analyzing how exactly your entire operation is being done. So we automate that. And like I was saying, we automate the workload distribution, 10 different drones, how you make sure that each individual drone is basically working for the same amount of hours and stuff like that, and the compliance. And lastly, what I was saying, but not the least, the dynamic integration of robots and changing workflows. How your clients, your merchants, you as the execution partner, the drone service provider out there, can actually come together on literally tangibly on a single platform. Not talking about coming on the single page, but rather coming onto a single platform, so everything remains very, very transparent. And every single thing that these robots done basically create a very transparent a value chain for every single of these entities that are going to be a part, I believe, because they need to be a client, they need to be an end user, there need to be sort of a middleman, a merchant, and there need to be the service provider out there. If you want to create an actual scenario of how things are being done in the real world. So with that, we believe the value proposition that we are working on right now and the products that we are pushing out and the kind of things that we're working on, we are right away right now reducing the pilot operational cost. So what happens is that the way that we are thinking about doing things is one drone, one pilot, one robot, one operator. But in the longer run, this is not what we believe. This is not how things are going to be, done. And the biggest bottleneck for us is basically humans that are going to be needed or that are needed even at this moment to operate these systems. We are talking about unmanned systems, and these systems can only be truly unmanned when there is the least interaction and engagement of humans within these systems. So with that, we essentially are trying to basically reduce the number of pilots, not eliminate, definitely not now, not right away, but reduce the number of pilots that will be needed to control these robotic systems. Right away, right now, we claim and we have already done 6 drones simultaneously, 6 robotic stacks simultaneously from a single human pilot. And this is not a technical limitation, saying 6 drones. This is more of a human limitation. I mean, technically, we believe we can do even 300, but it won't be humanly possible. So that is why we are taking it, as the most optimum sort of a number, as in like a single human can actually fly and pilot 6 different drones, and thus can actually reduce your end cost. So if you're doing logistics, if you're let's say even spraying pesticides, using in agriculture, flying for supervisions, then we believe that a highly automated system should allow you to fly 6 different drones by a single person. Then moving forward with the whole software stacks and everything that I talked about, we are here to reduce the mission planning time by about 90%. We reduce the time spent on management and coordination, because now this is a huge problem. Any mission that you need to do, you need to coordinate and manage with a lot many different people. There's going to be a pilot, there's going to be a supervisor, there's going to be a person who will specifically be focused on making sure that the end result is something that the client can actually use, and so on and so forth. So there's a lot of time and effort that goes into that. We have our whole sole aim is to basically reduce that. Then we are here to reduce the errors, troubleshooting, and compliance that needs to happen with these missions, with these operations, and with the pilots and the client feedback that we've got. We believe that we are able to reduce by about 98%. So the idea for us is essentially to streamline first the operations, increase the security of your operations, provide you higher scalability, visibility of every single aspect to every single entity involved in the entire operation, and in turn reduce the entire productivity of what we are talking about and what we are doing. And in doing so, we basically enable all these operators, service providers, enterprises looking to integrate these robotic systems in order to focus, like make them focus on their day-to-day operations, on taking care of their clients and customers, and not waste time and resources on undifferentiated heavy lifting. You cannot keep on redoing and redesigning a wheel, whereas you can basically take just 2 wheels, create a cart, and move along and accelerate and take a momentum. And our idea is that we basically want to become this wheel now, which allows your cart to basically move at a higher momentum, and not have you redesign a wheel altogether and again changing the just the axles or the bars or stuff like that. So we want you to gain momentum, use what's already there, use the base, and create a business out of it. So we believe what I just said, handling the undifferentiated heavy lifting. Any enterprise out there looking to utilize and integrate robotic systems at scale, in an environment where multiple of these robotic systems can work together, will need an surety in 4 different segments. They will need to make sure that whatever you do is completely transparent, completely secure, highly scalable, and the cost basically comes down. So in order to do that, what we have realized and what we have understood, that there are specific segments of technological stacks which are either non-existent or completely scattered across different platforms, across different spaces, maybe someone is working on something like one specific thing, and other two are working on something, but people haven't been able to basically bring all of them together onto like one stack and say that now this becomes your end-to-end solution, and you can just have it. Now this becomes your wheel. You can take it and just gain momentum. So this is our basically proposition, that we bring all of these different scattered or non-existent tech stacks onto a single platform, where we bring all the real-time visualization tools, management, analysis in a more of a no-code platform situation. So your team doesn't need to have too high technical understanding of what's happening, uh, uh, or even if you do, then there are certain APIs that you can directly integrate to, and stuff like that. So it becomes really easy for you to basically just connect and just go ahead and run your business. So the idea for us is to be like we are completely hardware agnostic and support all autonomous robotic systems across different segments, starting with drones to rovers to ships, moving forward, maybe hopefully even controlling your self-driving cars. But yeah, the idea remains the same. We are here to basically make sure that multiple robots can cohesively work together. Now I'll just sort of dig deep into what we have to offer, and then once that is done, we can definitely take some questions. I'll hope to basically not take too much time. So the first aspect of what we have is basically the control and commanding, which is also the most important part. So with our control and commanding software, we are basically creating a hybrid tech stack, which means is it is independent of internet, can still work with internet. When you have internet, it will be able to dispatch every single thing on the cloud. So this is a cloud connected a software command and control stack, which can connect with your hardware robotic system through RF tethered Wi-Fi, LTE, 5G, satellite communication. Pretty recently, we basically did control a drone 2,500 kilometer away, sitting in Delhi. The drone was flying in UT. Definitely a lot of safety precautions were taken, but we were able to test it. So that was an amazing experience. This software stack is capable of connecting, like I said, 6 drones. We are able to stream you the pilot 6 video streams simultaneously for better awareness. We this can fly anything that has audio pilot, PX4, ROS, or any other custom integration. I mean, even DJI systems we'll be pushing out in another 2 months or so. So this stack essentially allows you to authenticate, the pilots, the robotic systems. There's one more important thing that we do is we are basically FAA and everyone else is talking a lot about remote IDs, and people are coming up with amazing solutions where you need to, let's say, integrate a hardware system, a hardware key, or stuff like that. We are doing this completely through software. We are creating a unique remote ID of each individual drone, and then we can identify that drone irrespective of whatever you change in it, until or unless you change the autopilot system. So till that point, you change anything, we'll still be able to identify your individual robotic systems. So we use that, and then we bring weather forecasting and all of that directly within the platform. The integration of UTM system directly within the platform, so you don't have to go to like multiple platforms and search around and take documentation and stuff like that. So we are already working with UTM providers like Navifly to basically provide that. So these are all the things that are basically in this. A lot many things, but I won't talk much. We can basically talk offline afterwards. Moving forward, whatever is being generated on that software stack is essentially sent on the cloud once you have the internet connection. And from there, we have got specific packages. So we are trying to create more of an internal app store, much like how you have Android and then specific app. This allows us to be both vertically and horizontally scalable. So in those specific packages or apps or whatever you want to call it, we have an operations manager. This essentially allows you the capability to see every single asset that is currently live, let's say flying across the globe in real time. So you can see the path, who is flying, what speed, altitude, and all of that directly onto the cloud this thing dashboard. Then we also manage your orders in the whole lifetime of theirs. So they're in progress, completed, they're cancelled, pending, or all the different orders you have. Then we allow you to segment your entire operation into 3 different layers. So you could have an ecosystem, then a hub, and then a station. And this could be dependent on geographies or applications depending on the end user. So all of those can actually be done. Then we make sure that pre and post mission data logging is there. So before the drone goes up and after it comes back, all the specific things that you have done in terms of checklist and all of that basically get stored and can be accessed any point of time that you want. And then we also utilize the analytics. For example, we want you to reduce the time between when you prep the system to the time when you actually, click fly. So because you are essentially behaving like an airline, and as an airline, your whole sole criteria is basically to have most of the system up and running and not, not on the ground. So the idea for us is basically to reduce the time gap, and we provide analytics and stuff like that using the data back to you. So all the data that we are taking in is essentially used for, providing better decision making capability back to you, the users, so they can optimize the entire operation and not just see what's happening. And then we also manage the assets internally, so you could be having like 10 drones, 20 different batteries and stuff like that. So even the batteries optimization and everything will basically come into picture, where we'll be able to tell you precisely, which different drones, how definitely the batteries behaved and stuff like that, and if the battery has the capability to do another mission or not. Very very minuscule specific things. Moving forward, we're also, like I said, taking care of the maintenance. So we've got a specific maintenance application for you. This takes in all the different aircrafts and other robotic systems that you have got, and then it basically automatically creates a sort of uh, uh, the summary of, how exactly each aircraft is behaving. Does it needs to be put down, or they needs some maintenance, or it's already good to go? And we also digitizes the way that you do maintenance and breakdowns and, all of that. So every single part of your entire operation that you need to do, we basically have divided into, specific apps, and then you can utilize that. It's all automatic. You don't need to manually put in anything. That's the whole criteria for our complete architecture, because we want it to be, as less uh, uh, needy of human interaction or, engagement as much as possible. Moving forward, this is something that we're going to be launching pretty soon. This is very interesting for us. We're basically launching a cloud-based simulator system, and this is aimed at educational institutes. This is aimed at training institutes, which are actually looking to, train the pilots of the future. This is aimed at manufacturers also, manufacturers who would want to train their clients uh, without actually giving them the real drone to fly. They can basically ask their clients to basically fly it in a virtual environment, and, and gain the understanding how exactly it behaves, and then they can actually go ahead and, fly a real drone. And as well as the developers who would want to basically, create automated missions, run AI scripts and stuff like that. So this is essentially aimed for that. If anyone would want to get in touch, I believe Dr. Ruchi and everyone else basically works a lot in STEM, would love to talk about this, and, and see where exactly we can put it. Lastly, what I want to show you is basically the client and merchant ordering engine. This is basically the front face for any operator out there. You could be having a merchant in between, like a logistics a workflow, or just a client which would want to access what exactly you are offering and stuff like that. So this will act as a portal where you don't have to individually create, different portals. You can just access one. It will have your name on it, and any client that basically gets in will basically be just your client and no one else's. So this portal allows you to have a very generic engagement layer to any client or merchant that you want to have, and then it also provides the same transparency of you booking a Uber and seeing exactly the Uber coming in, every single thing happening. The same way, whatever drone operations that you do, your client will be able to see them transparently if they essentially use this. So this is what we have. I mean, we are working on a lot of different things, but this is something that we have right away right now, which we are already working with people and providing different companies. We are completely agnostic of use cases and industries. We are very focusedly working on logistics, but now we are also working on agriculture, public safety, infrastructure, and all. And currently, we have and we are providing a ready-to-use solution for enterprise drone operations, where you can remotely control and manage them, BVLOS operations and all of that. We've already done cellular connectivity and stuff like that. So those have been some really amazing learning opportunities for us. So if anyone has, any questions, any doubts, would love to answer. Lastly, we believe that, the kind of architecture that we are building, which we're calling as a universal stack, has a very similar potential to revolutionize unmanned robotic infrastructure in the same way what AWS did to cloud computing. So we believe as we move forward, we are able to, more or less generalize it more, understand more from the clients and the users, and basically create a set platform, sort of a wheel that no one will need to reinvent, but they can utilize it in order to gain the momentum. So that's it from my side. Thank you so much. Would love to take questions.
Thank you so much, Nishant, for your amazing and intriguing presentation.
Yeah.
And once again, you don't need to surprise us with your work. We have a question from you that is this available for developers for open source?
Not exactly. We definitely are. So it's not open source, but we can definitely allow people to utilize our APIs and SDKs. So that is there.
Got it. I don't see any more questions here, Nishant. And I guess you might find a lot of takers of your platform here. And I hope you make the most of the network that we have built for you. Thank you so much for being a part.
Thank you so much. Thank you.